So thank you everybody for joining. The title of this webinar is Performing LiDAR Surveys in Hard to Reach Areas with Complex Elevation, where in more detail, we'll also look at the case of Costa Rica. We'll have this webinar today in English. And by the way, tomorrow at 6 o'clock GMT +3, we'll have another webinar on the same topic with the same panelists, only in Spanish. So in case you prefer that one, you will be able to join as well. So a bit in general, first about the webinar. So first, I will introduce to you the LiDAR flight planning tools of UgCS expert. After that, Maxim from TOPODRONE will talk a bit about their LiDAR systems as well as the software. And then when we go on to the third part of the webinar, then Eduardo will talk a bit about the main topic of the webinar, which is LiDAR flight planning in hard to reach areas of Costa Rica. The approximate duration of the webinar is 1 hour plus the Q&A section. I urge you to please, if you have some questions, put them in the Q&A section and not the chat. You can use the chat for just, maybe if there's some technical problem at some point during the webinar, you can mention that, or if you just want to send us some message, you can use the chat for that. But for all the questions, please put them in the Q&A because some of them will be answered over text. We also have people from our support team here, and some of them we will also try to answer live. Plus, additionally, the recording of the webinar will be available after, so you'll just be able to find it on YouTube so that it will be sent to you to your email. So I think then, without further ado, let's get started with the webinar. So first, very briefly about SPH Engineering, who we are. So we are active in the world of drones since 2013. We're based in Riga in Latvia. We have 4 main business lines, which we're working with. Today, we'll focus on UgCS, flight planning software for drones. In addition to that, we also have UgCS integrated systems where we integrate different sensors with drones, such as ground penetrating radars, magnetometers, bathymetric sensors, as well as we have the only in the world terrain following system for DJI drones. So in case you're interested in that, you can check out our website there. We also do drone show software as well as some custom consulting and development. So as you can see here as well, we have partners all across the globe, as well as customers using our software in most of the countries in the world. The main industries we're working in are surveying, data collection, as well as, in the case of drone shows, entertainment. What do I do? I'll just talk a bit about this briefly as well. I'm Kristaps. I'm the product owner of UgCS, flight planning software, which you can see here on the screen. I'm sure many of you are already familiar with that, but in case, I'm assuming there's probably some of you who are seeing this for the first time. So this is how the interface of UgCS looks like. We support most popular drones available on the market, including DJI enterprise drones, so M300, M200 series, M600, as well as other drones. The full list of drones is available on our website. So the software itself runs on your computer. So it's going to be Mac or it can be PC. And then you connect your DJI drone either through the smart controller or through an Android app. So all the flight planning is done here in 3D. I'll also demonstrate this to you in just a moment. Yep, I hope this list gives you somewhat of an idea of how the software looks like, at least a general overview. And so now some of the points why the software is used by so many of our customers all across the world. So firstly, it's because it installs locally. There's no need to use any browser interface, nothing like that. So everything runs quite quickly. You can use this on either PC or Mac. And yeah, so it's, like I said, local installation. You also have a whole 3D interface with elevation. The elevation by default, we're taking from SRTM4 elevation data. And then for the maps, you can actually choose what map layer do you want to use. But so here, by default, we're using Google Maps. And then in addition, you can also choose Bing or some other map sources. I can talk about this later as well. And also you can ask questions about any of these points, basically. So you can also use custom map overlays, which is actually also quite useful when you're flying in remote locations. So for example, you can fly over a certain area, take pictures, stitch your own map together import it into the flight planning software. And then when you'll be flying over this area the next time, or for example, with the LiDAR system, then you will be able to see in a lot more detail what will be located underneath the drone and if there are any obstacles or things that you should be aware of. Similarly, also, you can plan your flights according to a custom digital elevation or a digital surface model. You can plan flights, of course, with terrain following. So this is one of the main features why customers are using our software. Going back here, you can actually see this is the elevation profile that is constructed of this route. And so here you can see how the terrain following works. Additionally, also, you can catch maps for offline use. So when you know you'll be located in an area where there'll be no internet connectivity, then you are able to select a custom area of a size up to 100 square kilometers per area, and you can download that for offline use so that you know in these remote areas you will have access to maps as well as elevation. Additionally, one of the things is that our software supports not only DJI drones, but others as well, such as Autopilot and PX4. So if you have, for example, a fleet consisting of various different drones from different manufacturers, then you can use a single software to control the whole fleet. Additionally, you can also create routes from KML or CSV files, and the main focus of today's webinar is the LiDAR toolset. So about this, I'll now talk a bit as well. So essentially, when you're planning your flights, there's, as far as the altitude goes, there's two main ways how you can plan your flights. You can either plan them according to AGL or above ground level altitude, or MSL altitude. In general, with LiDAR flights, you want to be flying according to AGL altitude. And this is also kind of where, like I said, UgCS stands out, because here you can either use the default elevation source, or you can actually import your own elevation source if you know that this is a lot more accurate with a higher resolution. And you can fly according to that and keep a constant distance between the drone and the ground level. So this is one of the things for LiDAR specifically, which you can see mentioned here above. For LiDAR, we're using the field of view angle to calculate what should be the spacing between the between the two like adjacent survey lines. So I'll also show you the software in just a moment, but yeah, that's at least initially so you can understand how is it all calculated. It will make more sense when we look at the software. And another interesting thing that we have developed for the LiDAR toolset for flight planning is, so for the turns, you can adjust the turn corner radius. So you can see this black line here. This is showing basically how the flights are normally planned, for example, to UgCS Pro license. And so these turns where you can adjust the corner radius, which is the green line, this is what you can already plan with UgCS Expert. Advantage of this is that you can gather data that's way more accurate, because the drone will have less jerks and it will fly more smoothly throughout the whole planned mission. Additionally, one thing we have implemented is the ability to fly these loop turns in corners. So you can define what should be the angle between two lines that come together at which the software should add a loop turn. For the loop turn as well, you can define what should be the corner radius. You can define also what should be the length, basically the straight flight after the drone does the turn. And so using this, you can also gather more accurate data, and you can ensure that actually the IMU of the LiDAR sensor will be additionally calibrated using these turns. So about the UgCS Expert license, what are the main features of that, and why should you look into that for LiDAR flights? So first, it comes with two important flight planning tools. First one is the LiDAR area, and the second one is the LiDAR corridor. Both of these are planned according to the field of view angle, and both of these also come with the options that I mentioned in the slide before. So you can adjust the turn radius, and you can also use loop turns. Additionally, we also support calibration actions. So you can either add them in the route itself. So you can, for example, add the figure 8 calibration pattern before the LiDAR area. You can add it after as well. And then additionally, as an action, and this I'll show in just a moment, you can add either figure 8 or U-shape J-hook calibration patterns as well. And so yeah, with UgCS Expert, you can just go to our shop, so shop.ugcs.com, and you can read all about it and see whether it is for you. And by the way, we also have a free 14-day trial that you can apply for. So what I mentioned about the pattern tool is that here in the software, I won't be able to show this on the demo because for that I need to have a real drone connected. But basically you have this pattern button, and after pressing this, you can then choose if you want to use the figure 8 or the U-shaped pattern. And then after you have chosen it, you can simply place it here on the map, and then the drone will fly the calibration. So this is useful if you, let's say, compare it to the IMU calibration action that you can add in the route itself. So this one's useful, let's say, when you fly a larger route, and then, for example, you do the first calibration that's already in the route at the beginning, and then when you need to restart flying the route, then this is important, because as soon as you take off, you can do the calibration using the pattern action, and then you can send the drone to continue the route from where it left off. And so here as well, in the screenshots, you can see a couple of other things. So in the screenshot above, you can see the adjustable corner turn radius, as well as this is the IMU calibration pattern. And then in the screenshot below, you can actually also see the loop turns. But I think it will make more sense when I show you the software itself. So I think maybe let's jump on over to that. So I'll just stop this screen share, and then let's just go to UgCS screen. So just give me a second here. And by the way, while I'm showing all of this, you can think about, like, maybe what questions do you have and what would you like me to answer at the end of my part. But basically here now, I'll demonstrate the software itself. And after the software demo, we will move on to Maxim's part where he will talk about LiDAR sensors. So hope you should be able to see the screen. So Maxim, can you also see the UgCS screen?
Yeah.
Okay, perfect. Just checking.
Okay.
All right. So like I mentioned before, you can basically plan your flights in a 3D environment, so you can kind of see how it all looks like. And now let's just zoom into some location where we can plan our flights. So let's, for example, go somewhere over here. Just move these zoom controls a bit out of the way. So in general, in UgCS screen, everything is kind of divided into two parts. So everything that's here on the right side of the screen is concerning your drone control. So up here, you can see the drone that's currently connected. This is just an emulator drone, but this should be enough for the demo. And then everything that's here on the left side, this is concerning your route planning. So I think now maybe let's get started with planning the flights. I'll make the screen just a bit larger for me, and I hope that you can still see it. If there's some problem, just let me know, but I hope that this should be okay. I'll just move some zoom windows around here, and I think we should now be good to go. So now you can see here on the left side, I have already one route created, and then I think for this route, we can already start actually planning the flight. So let's start with the LiDAR area. So for the LiDAR area, you can select the LiDAR area tool over here. And then holding down the shift button, you can press and add points here on the map. Once you're done with that, you can press on enter to complete that. And then you can also adjust the direction angle using this arrow here. Now let's see if it might exceed the fence radius. Yeah, the default fence radius is about 500 meters. So let's just decrease this. And you can also, if you want, you can change the fence radius in the profile. But now, to maybe simplify things a bit, I'll just make the route a bit smaller. And I hope that now, yeah, so now this should be okay. So you can see now the software has already calculated and constructed our route. You can see that the route will start from here, I think. Yeah, so this you can see is waypoint number 1, and it will, of course, go on until there. Now, after this, I think let's maybe add already a IMU calibration action. So we can go over here to pattern. And then, for example, after LiDAR area, we can shift click and then again add the pattern action. So let's add it, for example, somewhere over here. I think this should be good. If you want, you can also move it around, basically add it to where you want. And let's actually add another one, but the other one we will add here at the beginning, and then also we'll move it to the beginning of the route. So let's just go here. I'll add another pattern action over here, and then basically here you can see this is the order of the segments in the route. So there's this pattern tool I can take and move like so to the very beginning. So you can now see we have a simple mission constructed consisting of 3 segments. So we have the pattern calibration, then we have our LiDAR area, and then after that we have another calibration pattern that the drone will fly. Now let's just briefly take a look at this LiDAR area and let's see what parameters are here and what should we adjust additionally. So one of the first parameters you can see here, this is the field of view angle. So the angle basically is different for each sensor. And in this case, let's maybe use an angle of something like 70 degrees, which is a bit more popular, I suppose, among sensors. Now, next, the altitude mode, you can see it's currently set to AGL. And I think let's for now keep this as AGL because in most cases, you do want your drone to follow the terrain as it's flying. The flight height, let's change this. The typical flight height for LiDAR surveys can be somewhere around 50 meters. So let's change this to 50. And then next, you can see the line spacing. So line spacing basically is, you can set this either according to a certain side overlap, which in this case is set as 30%, or you can also use a specified side distance. In this case, I'll just use the overlap. Then additionally, you can see that here, the survey seems to kind of cut off a bit short here. So I'll just take this corner, move it around. And so you can do these manipulations with, at least in case when you need to expand it a bit, then you can do that. And so now I want to show what I was showing there in the presentation. So how can you adjust the corner radius and how can you make the drone do the loop turns if you need to? So now to change the corner radius, you can just go here. So this is the corner radius parameter. By default, it's set to 6 meters. And if you need to change that, you can simply select it and then enter a larger value. Oh, sorry, somehow selected all of it. Let's just go back here. Yeah. So now instead of 6, we can enter something like, let's say 20 meters as the corner radius. And so now you should see that once the route is calculated, you can see that the corners are now a lot more smooth than in the previous version of this route that we had. And then additionally, in cases when you want the drone to do a loop turn, you can also do this by changing the loop turn angle. So for example, if we set the loop turn angle, let's try 90 degrees first, it might do the loop turns now on some of the turns. Yeah, so now I can see here, in cases where the angle between those 2 lines is larger, then the drone will do the loop turn in those cases. Additionally, also, you have 2 types of turn types. In UgCS, we have adaptive bank turn and we have stop and turn. But with LiDAR tools, of course, you want the drone to do the adaptive bank turn so that it can fly through the corners with a specified corner radius and also perform the loop turns. What also mentioned with the loop turns is that you can actually change the length of the straight flight after turn. So you can see currently this is set to 10, and you can also, for example, increase this if you need to. So this is how you can construct a simple area scan mission for LiDAR. Of course, if you want to fly a larger area, then you will need to increase the fence radius. So I'll just show how you can do this as well. And then we can easily now expand the area. So let's just go to profiles. This route should be constructed for M300, I believe. And then here we can go and then change what's the fence radius. So, and I think that now we should be able to increase the size of this route even more. Yeah, well, then you can see how it looks like now. I'll just move this corner outwards a bit as well. Yeah, so this is looking already quite good. And then next, we can go here into parameters because I'm very interested now in seeing what will be the height of the flight with respect to the elevation. Plus, additionally, what I'm interested in is the total length of the route. So you can go here into route parameters and then show elevation. And so we are now presented with the elevation window. So what information can you see here? You can see, firstly, the total distance the drone will cover, total estimated duration. So, for example, you can see that for this flight, the drone will take about 23 minutes to fly through it. You can see the total amount of waypoints, as well as the minimum and maximum AMSL and AGL altitudes. So this is these are kind of the basics of how do you plan an area scan route in UgCS. And I'll just very briefly show the corridor scan tool as well. And I think that then we will be able to already move on to the next section of this webinar. But keep in mind, like all questions that you have, I will be able to answer them in the Q&A. So if you have some specific questions about flight planning of UgCS or features that it has, then just keep them in mind, put them in the Q&A, and then I'll be able to answer them. And so for the corridor scan, it's quite similar. So there, again, you just press here on the plus button, then you go here to this window that allows you to create a new route. Click next, then you need to choose what drone do you want to create this route for. I'll just, again, choose DJI M300 drone. And so now let's maybe actually already start with the calibration pattern at the very beginning. Let's maybe move to a slightly different location. For example, here, let's say we need to scan with LiDAR this whole road, and maybe we will be taking off from this location here. So for that, we can go and first add our pattern action over here. And next, after the pattern action, we can actually proceed with already creating the corridor. So we can press here on LiDAR corridor, and then we can also enter our desired flight height. We can enter the field of view angle for the sensor. And so with this information, we can proceed with creating it. So the creation of corridor is quite similar to the area, except that, of course, you'll only be adding these single points. So the way I'm doing this usually is just like, in general, first click and place the points kind of roughly, where you want them to be. And then once you're done with that, press on enter. Here, let's just click on OK. And so now, once the route is calculated, you can see in this case, the corridor is only going in one direction. If you want it to go in 2, 3, or even more, then you can increase the width of the corridor. In this case, I'll see what 100 meters, what a width of 100 meters will give us. And so here you can see that the corridor now as well is going in 2 directions. And then additionally, when you need the drone to, for example, follow a certain point or certain line more accurately, for example, here you can see how the road kind of diverges. You can take the point that's here in the middle, move it over here, and do the same with any other point star in the middle of these lines. And you can basically make as many adjustments like this as necessary to make the corridor correspond better to whatever linear object that you're surveying, whether it's power lines, maybe some river, a road. So you have all these features here in UgCS. So now I think the corridor should be calculated. Let's wait a bit. Yep. And so then finally, we can add another pattern action after the corridor is done here. Here I will need to, I believe, specify the width of, let's say, 20, and then I think, yeah, this should be good. Yep, and then of course, in the corridor, you can add other actions. For example, if you're using DJI L1 LiDAR, there you can also add the possibility to trigger the camera so that you can generate a colorized point cloud. And there's so many other features I could talk about. I could probably go on for hours about this. But I think now it's maybe time to pass the torch on to Maxim from TOPODRONE. And to those of you who have some questions about UgCS in the future, well, I mean, further in the webinar, I'll answer some of them that I see now here in text, and some others I'll answer in the Q&A. So, Maxim, now the floor is yours.
Thank you, Christoph. Thank you for a good presentation. It was very useful for me. And as soon as we are using UgCS every day during testing of our LiDAR system and when we provide training for our clients. And today I'm going to talk about LiDAR survey. And first of all, my presentation will, I would like to describe my presentation, how I will arrange it. First of all, I will show all kind of LiDAR system which were designed and produced by TOPODRONE. And after that, I will let my friend and our very professional user from Costa Rica to make a presentation about real survey project which were made by TOPODRONE LiDAR system, and we process data together with Eduardo, and Eduardo will follow my presentation. So Eduardo, if you have any questions, be free to ask me any question during my presentation. I will try to answer it, and it will help me to arrange presentation in a better way if you make if you provide live questions as well. And of course, Eduardo will answer your questions from his real experience of using UgCS for mission planning in very hard to reach areas of Costa Rica, and he will answer questions about using LiDAR systems and how it should be used in dense forest areas, in mountain areas, how to fly without any connection to the drone, how to fly without any connection to the internet. And of course, in all these cases, UgCS helps us to prepare mission and to drive the drone without any accidents. So let me start my presentation, and if you have questions, feel free to ask them. Okay, I will share my screen. As you know, TOPODRONE produces wide range of LiDAR systems which are based on Velodyne sensors and LiVox sensors. And right now we cover a whole range of different. We cover a whole range of usability of our sensor. First of all, we offer LiDAR Avia. It's the most affordable LiDAR solution, which is based on LiVox sensor. And it has high precision Honeywell IMU inside, the GNSS receiver inside, and microcomputer, and it works much faster in comparison with DJI L1. Why? Because with using of any of our LiDAR system, as well as the LiVox Avia, you are not. It is not necessary to make so many calibration patterns of the trajectory. It is as soon as we use high precision IMU inside and GNSS receiver inside, it's not necessary to stop every 100 minutes, every 100 seconds the drone and start special calibration patterns of the trajectory. And if you compare with DJI L1, which use the same LiVox sensor, you will have to stop the drone every 100 seconds. And you will have to stop the drone every turning part of trajectory and start to move special calibration patterns. So in this case, our LiDAR system, even which is based on LiVox sensor, provides better, much higher efficiency and better accuracy as soon as we use more powerful components like IMU and GNSS receivers. And of course, we work with Velodyne. Velodyne is our major supplier of LiDAR sensors, and we have a wide range of sensors, started from TOPODRONE LiDAR High-Res, which is the most affordable Velodyne sensor, but it was specially designed for mapping, and we use a specially calibrated Velodyne sensor inside. So it provides a very good and accurate point cloud and has all advantages of high precision IMU and GNSS inside. And of course, we use and we offer and widely use TOPODRONE LiDAR 200 Ultra, which works up to 200 meters altitude, up to 200 meters working range, and it covers a huge area, and it provides a great results for large area mapping. And of course, we use HDL sensor, which was firstly designed for mapping by Velodyne, and it has great results in terms of accuracy, in terms of density of point cloud, in terms of minimum level of noise, but it has a little bit higher price. And if we compare all the sensors, I would say that TOPODRONE LiDAR Avia has the most affordable price, but less efficient. TOPODRONE LiDAR High-Res provides high quality of point cloud, and it is more efficient in comparison with LiDAR Avia, and it has a little bit higher price. And TOPODRONE LiDAR 200 Ultra provides the most efficient capabilities of the LiDAR, and it can work from the higher altitude, which is very important if you fly in the mountain areas. But it has a higher price. And of course, if you need the most powerful, the most accurate results, you should look at TOPODRONE HDL sensor. And of course, just a few months before, we created a new one solution which works up to 300 meters altitude, which can be installed on helicopter, electric helicopter, and which can fly with more than 1 hour and 1 hour and a half, and can cover more than several square kilometers, more than 5 or 10 square kilometers per flight with high precision LiDAR data. And we will show all this equipment on Intergeo, and we invite you to visit our stand. And on our stand, you will find some of our users who have been already using our LiDAR system. And I think some guys from UgCS will come to the stand, and you will find a lot of information, and you will find some interesting products which will be announced on Intergeo as well. And of course, all our LiDAR system can be combined with cameras, and TOPODRONE design and produce two types of cameras, 24 megapixel cameras and 61 megapixel cameras, which can be installed on Matrix 200, Matrix 300. It provides better quality of the images in comparison with original DJI solution, because it has a wide working range as soon as we use Sony sensors, and it provides 61 megapixel resolution. So you can fly higher, you can change lenses, and you will cover a bigger area with better data sets. And the main advantage of these cameras that it is possible to change lens from RGB original lens like 24 millimeters, 80 millimeters, or 35 millimeters to multispectral lens, and from the same camera you will capture multispectral data, RGB data, and you have a great flexibility in the field, and you have a great coverage of the data. And of course, the resolution of the data is much higher in comparison with DJI P1 or any other sensors which are available for DJI Matrix 200 or Matrix 300. And of course, all these cameras provides a real video link, and it can be combined with LiDAR. And when you make a LiDAR survey, you can see on the screen, you can watch on the screen what you are capturing right now, what is the quality of the data, and so on. So it has very powerful solution for you. And of course, all our LiDARs can be installed not only on the drone, but it can be installed on the car or on a backpack. And if we compare datasets which are captured from the drone or from the car, you will see that it can be combined together, and you will cover forest from high altitude with the drone, and you will cover roofs and so on. And after that, you can make survey from the car, for example, and you will catch small details which are close to the ground. You will catch very high precision data sets from the ground. It is amazing advantage of our LiDAR system. Not only the efficiency of our LiDAR system, but additionally, you can change the way how to use it. You are flexible to change the payload from the drone to car or any backpack, and you have a great flexibility as well. So, and right now, today I'm not going to show how to process data. Maybe in some today I make some announcement of our new features of our software, which was designed especially for Eduardo when he made a huge project of LiDAR survey in Costa Rica, and he asked us to help us to process data when he had more than 30 flights. In this case, we designed a special workflow, which right now, which will be available for all our customers within few days, and which this workflow helps to process all data sets from 30 flights in one click. So you don't need to do anything, just to upload all data sets, and all data sets will be processed automatically. You will generate point cloud automatically. You will calibrate the LiDAR automatically and make strip alignment automatically. So you don't need to use any additional software to make a strip alignment or LiDAR calibration. Everything is included in our TOPODRONE post-processing software. And of course, it has a batch processing. So you can add a lot of flights in one data set, and you will process all flights together. So, Eduardo, could you show us a real... and what I forgot to describe. First of all, I would like to introduce Eduardo. And I know him for maybe 4 or 5 years. And first time he arrived to our training in Finland. We provide, and in a heavy winter, Eduardo arrived to Finland to pass our training for photogrammetry survey. And those time, Eduardo, to tell the truth, he didn't know anything about real photogrammetry. He didn't know anything about real workflow of data processing when you don't use any GCPs, just to use only onboard PPK system, just to use camera and how to get accurate results. And after this training, Eduardo decided to buy our camera, X4S camera, which was compatible with Matrix 200 drone. And within few years, he had a lot of jobs which was performed in Costa Rica. And you know, in Costa Rica, there are a lot of rainforests, and it is difficult to reach the place, as you can see on this photo. And it's very difficult to place any GCPs. In this case, Eduardo was interested in our PPK solution for photogrammetry. And after the training, he got know how to process the data. And within few years, he got a lot of projects, successfully realized projects, accomplished projects. And after that, he chose our LiDAR system and for LiDAR survey. And he came to us to Switzerland, and we spent maybe 3 or 5 days. We provide all kind of training, how to use the LiDAR, how to make a calibration, how to plan the mission in UgCS. And in those times, we already realized that only UgCS can provide you efficient tools for mission planning. In case if you fly in the mountains, in case if you fly in forest areas. And of course, for LiDAR missions, in those times, we use UgCS Pro software, and we have had to create all calibration patterns manually. It was a little bit complicated, and it was a little bit tricky. But right now, we use UgCS Expert, which is much easier and much easier to create all parts of LiDAR trajectory. And finally, after the training, Eduard left Switzerland, and within few years, he made a lot of great projects of LiDAR survey. And one of these projects will be shown by Eduardo today. And if you have any questions, I will answer or Eduardo answer. And I will show some new parts of our software during this presentation as well. So, Eduardo, could you start your presentation?
Thank you, Maxime. Thank you, Kristaps. Well, yes, Maxime made it short how our journey began and how we started using the top.
Yeah, I will stop sharing, and you are welcome to share the presentation.
And how we started our journey with them. So right now, we wanted to share this project, but it was kind of challenging at first, because when we got there, the forest was just very dense. Okay, you could see. Let me stop sharing here. All right, you can see that in Costa Rica we have only 2 weather seasons. We have rainy season or dry season. So probably the best time to do these things is on the dry season, because there is less forest cover. But many people need to run these tests during the winter so they can build during the summertime. So it was really hard for us to get all this information gathered quickly and accurately without LiDAR. That's why we started on going through all of these equipment. And in this particular project, it was very important to get it done quickly, because it's going to be a very big land plot, and they have a lot of permits to go through. So that's why they chose us for the project. Our company's name is Survey Corp. They had been in touch with some of our previous customers, and they got a few recommendations. So when we got to the job site, as you can see here on our image on the right, it was all covered by trees. So that made our assessment to the job change dramatically, because we had to just take the drone to fly lower, to fly at a low speed, let's say at 7 meters per second is how we were flying, between 5 and 7. And we kept the drone between 40 and 50 meters above ground. It was very important to not go over those 50 meters, because we needed to get the richest quality, the best quality that we could get to process our results. Now, I have been using the UgCS expert for this. We started with back then with UgCS for doing the photogrammetry, and I was really satisfied with the results of UgCS for photogrammetry, so we chose it again for the LiDAR surveys. And this right here, you can see is the entire area. Okay, it's divided into three sectors. There's sector number one that you can see right there. That one was not so complicated to fly from because we had a nice place for our truck, so we could just take off from the truck, and we had a nice spot for the base station. When we came to the second spot, which is this one I'm showing you right here, it was a mountain region. We had to go there on horses. Now we have before flown beyond line of sight part of our missions, but we didn't do this on this time because the trees here were very tall, and we wanted to be able to take over the drone just in case it was going to hit a very tall tree, and we had to take over twice because on the mountain regions there was just some very tall trees. So we used the horses to get there, and the third option, the third sector is this one right here, where you can see that we had to drive completely around the mountain, and it was really, let's say not challenging, but it took some logistics to get the drone to fly 200 meters difference in height and still get battery time and get enough area when we were surveying it. A total of 35 flights took us to do this job. I mean, we could have done it like in less flights, and we would have picked up the pace on the drone and picked up the height, but that is not what we were looking for. We were looking for the best results we could possibly get, so this could work for permits. Here in Costa Rica, in order for you to get permits for a land development, they need to do an assessment of the trees, of the bodies of water. There's 3 large bodies of water there, and if there's going to be any earth movements, they gotta be recorded prior to that, and the pre-design of the land plot must be submitted. So this is why we needed this to be the best it could be. Like we need to maximize the use of our tools. So when we finished, when we were working on the field, we were like, well, this is going to take some time processing. That's the first thing that came into our mind. So there's where I talked to Maxine and said to Maxime, and was like, okay, we might need some help on this so we can do it quickly and not take too long. So Maxime came up with a suggestion. He said, well, we're just gonna speed up what they have been working on before, so we can process this quicker, and you don't have to be doing one by one, which takes a lot longer. The other thing we have here is that we're working on the rainy season, so it's not like we could fly all day. We could have 2 or 3 flights per day, so we needed to be able to check the information quickly, so just in case we have to cover an area again, it would be much easier. So as you can see, it was really, well, I can show on this screenshot is how we can process all the flights at once, so you can see all the waypoints. We have a blank spot right there, but it was just I deselected it when I took the screenshot, but we covered all the area. This is the point cloud we gathered. On the left side, you can see there's a big body of water, a river, and it floods in the rainy season considerably. So they needed this to be very accurate, so they could run simulations to see where is the danger zone and where is not the danger zone, where they can safely build. As you can see here, are part of our results. To be honest, I was thinking that this was very covered in trees, and we might not get as good results. That's why we flew so low and flew slower, and we were actually very satisfied and impressed with the results. Not only what we got from the point cloud and the LiDAR, but how accurate it was for UgCS to fly with us. There was a tower. There was a communications tower at some point that we had to avoid, and it was very useful to have the no-fly zone feature on UgCS. So we were flying the mission, and we just avoided the dangerous parts. Well, then this is the elevations model of the entire process that we did. This is like one of our final products. As you can see, we covered the entire area. The area of interest was 235 hectares, but we surveyed in total 335. The main reason is that we needed to know outside of the boundary, how was the water coming into the property? If it was flat, or if it was a hill, or if it was a different kind of change of elevations. So out of the boundary, we moved about 150 meters. If we would have had to do this on foot, it would have taken a long time, and probably we wouldn't have been able to take so much information from outside of the boundary, because it would require a lot of work of walking and going back and forth and getting permission from everybody. So we just talked to the neighbors and said the drone's going to be flying. We showed them our permits, and they were like, fine, everybody cooperated. And this is the elevation model consisting also with the trees and all the layers in there, without the ground. I mean, with everything. This is not the part where we clean the ground. This just has everything: the trees and all the buildings and etc. And this is our final result. This is the contour lines. This is exactly what they required from us. So the developer could decide which were the better.
Eduardo, could you show? Excuse me. Eduardo, could you show the contour lines? Yeah, super.
Yeah. Right here in the contour lines, this is our final product, what our customer wanted. And as you can see, there is a lot of detail in this. And we that went to the field, and the customer that knows the field, when he looks at this, he knows that this is what the property looks like. We don't have any blank spots or anything. You can say, no, this is inaccurate, but no, we are really satisfied with the outcome. Here you can see all the mountain ridges, all the lines. It was really effective for giving a simulation of the river when it just floods, so they can definitely realize or take a decision how to assess the river and how to maximize the land plots. Basically, I'm putting it really close together. This is the project that we did, but it took us a lot of days. It took us about 3 weeks to do this, even though for a LiDAR, it's small, but we had to do many flights to get the best information possible. And we are actually pretty satisfied with it, because we got the most out of it, and the drone and the sensor, everything worked the way it was supposed to work. So it let us mind or worry about what was important for us at that moment, that was getting work done. You know, we didn't have to battle with any of the equipment. So go ahead, Maxine, you can take it on from here. If anybody has any questions, you can also.
Yeah, actually, I think thank you, Eduardo, for the presentation. I think maybe you would be the person who could also answer the question. It's been sitting there in the Q&A for a while. And by the way, a reminder for the rest of you guys, I see somebody also raised their hand. Like, please put the questions in the Q&A, and then we will go through them one by one and answer them. So one of the questions is, so maybe Eduardo, you can like comment a bit on what are the best practices when you have to deal with large terrain changes and varying tall trees. I know you mentioned this in your presentation and your speech, but maybe you can like explain again, let's say for somebody who's not that experienced, maybe with drones or LiDARs, for like a newcomer, for example. What would be your recommendations after this whole experience? How to what would be the safest manners? How to fly to take into account large terrain changes and potentially tall trees.
Okay, for the large terrain changes, my recommendation is that as much as it's possible, because I know it's not possible all the time, but as much as it's possible that you can fly parallel to the changes in terrain and not straight forward to them. Because when you're going parallel to the terrain, the changes of the flight path are not as abrupt as if you're going straight forward to it. So it not only keeps the drone more stable, but it helps you it helps the sensor collect more precise point cloud, because you're not having all those jumps. Now with the trees. With the trees is a good question. I mean, we had to take over the drone twice, right? Because there were some very tall trees. It is kind of tricky sometimes. You just have to, for example, here in Costa Rica, we don't have trees that are taller than 35 or 40 meters. So basically you could be safe if you're flying between 40 and 50 meters. But this becomes a challenge when you're in a mountain range. So if you have mountains and you have to fly the drone straight towards the mountain, it's a little more dangerous to hit a tree. But if you're going parallel to the mountain, it'll be easier for you to assess in every turn where is the next danger. Because when you're going parallel to the mountain, the drone goes. Let's say if you're going from top to bottom, every time the drone goes down, you can see the trees on the turns. So the two times we had to take over the drone, we already knew that was going to be a problem, that there was going to be a problem there. We were close to hitting trees about 15 times because we were flying very low. But since we were flying parallel to the changes in terrain, right when the drone makes the turn, you can see when is the next path going to be. So you can be ready to see if you're going to take control. Now, we only had to do it twice because the missions were planned correctly, and the drone would just gain altitude quickly. There was just these trees that were just amazingly high, and we knew we were ready for it. That when the drone was going to turn, we were probably going to have to take it over manually, and we did in these two times. It wasn't dangerous at all. I mean, the sensors in the drone, even though we used an M210, that is not so advanced as an M300 with the obstacle avoidance system. It's still the M210 worked perfectly. It noticed the trees, it slowed down. We took over safely, replanned that mission, and in that area specifically, we flew a little higher. But in the end, it was pretty safe. You know, specifically when you're flying slow, it gives the drone and the sensors time to work. Not if you're flying a little faster, probably takes a little longer. But I would say it was pretty safe. I mean, all of our equipment was safe in every single spot, in every single survey that we were doing. I don't know if I answered your question, or would you like? Do you have any other questions about that subject specific?
I think for now, let's consider this question answered. And, if to the person who asked that, if you have any more additional questions to Eduardo, then please feel free to add them. Another question we have for you, Eduardo, is, so did you have any instances where the drone went out of visual line of sight, or did you always keep it within line of sight?
Okay, well, my drone was beyond line of sight for a lot of time, most of this, but I had a solid connection. We have a range extender from a third party on our controllers, so we were surrounded by trees most of the time. I couldn't see the drone, but we had a solid connection with the controller. I'm not sure if we would have had the same results with the standard antenna, but with the range extender I have, it gives a very solid connection to the drone where you really can't see it, because in a flight path, our drone had to fly 1 kilometer before it began. And you ask, well, why do you have to fly it an entire kilometer before you start the survey? Can't you get closer? Well, we couldn't get closer. Those cliffs were very high. The drone, the forest was very dense, and getting there would just take 2, 3, 4 hours to get 3, 4 flights out of the day. So it was just better to fly from a distance where we could recover the drone, get it charged quickly, and probably do more missions, but it would be more time and cost effective and safe, because part of the things that we deal with when you do this kind of work in this area, in this part of the world, is safety. There's snakes, there's in this type of forest, when you're walking around, there's things that can fall. So when you have this expensive equipment and this delicate gear, you want to avoid danger as much as you can. So for us, it meant to at least have to do a few extra flights, because the drone was going to lose a lot of work time getting to the job site. But it was the safest way in order to protect the drone and to protect also us, in order to be able to complete the
Right, it's actually quite an interesting point I think you made, that like in these kinds of locations, you need to worry not only about, the drone's safety, but also your own safety as well, due to the environment around you.
Exactly.
Okay, so this also I'll mark now as answered. There's another question regarding the ideal height of the flight plan, but I remember you mentioned this, that like in most cases there you flew at 45 to 50 meters. Correct me if I'm wrong.
Yes, we were between when we were doing the mission planning, I planned it between 40 and 48 meters, and in the job done, like in the real world, it was done between 38 and 47 meters. We were very close to the trees at some points, right? But as I was mentioning, we really wanted to get the best results we could, and in order to get good results, you need to fly low, and if you can go not so fast, just try to go slow. And that's what we did. That's why in this area that is really not that big, because we have surveyed larger areas, but we chose this one because we needed a lot of detail, and there was a lot of forest. I mean, there's a part of the land plot, sector 3. There's probably a primary rainforest. There has never been anyone there doing anything but a small trail for the owner to keep the property lines clean. So we really wanted to keep below 50 meters and above 37, 38, so our gear would be safe.
Okay, all right, thank you. So I'll mark this one as answered as well. By the way, maybe to also kind of address the questions about the altitude and also about obstacles, I'll just mention from my side as well, because we also have had some experience flying in remote areas. For example, some of my colleagues were in Papua New Guinea, where they also flew with drones with LiDAR. And one of the things we learned there is that it's very useful if you already have, firstly, in addition to the default terrain elevation model that we have, if you're flying in very complex areas where the drone might get close to trees at some points, first thing, it's good to have another digital elevation model of the area. And plus, in addition to that, a digital surface model, because this will allow you to also understand at what height will the trees be. Of course, this isn't always possible to get such a model if you're flying over very large areas, but you can still at least maybe fly a bit higher, get some preliminary model, which you can then use for flight planning, or just to make sure that the flight won't get really too close. So one thing we did is that if you have both of those models, so terrain elevation and digital surface model, so then first you can construct your flight with respect to terrain elevation model. Then you can go ahead and convert the whole flight from AGL to AMSL altitude, so the altitude won't change. And then you can import the the digital surface model. And so then basically this allows you to compare the height of each point, as it will be AMSL, so it won't really take into account the digital surface model. So when you see the elevation profile, you'll be able to see the difference between each of the points as well as the digital surface models. This will also give you a bit more assurance, to make sure that you won't really get too close to any obstacles that are there. Okay, so another question I see is, what did you use for positioning in that location? Did you use RTK base station or PPK? So what was the setup there for positioning?
Oh, we used a PPK. We first, we used the GNSS base station. We fixed our point to the ground, right? There are two base stations we used. With one of the base stations, we flew sector 1 and 2, and with the other base station, we flew sector C. Since we would have to go around just too much to go and start the base station B, again, that would take us 3 or 4 hours just to fly. So that's why we used another one. So we fixed our base station and we used our base station there, and we got it to record raw data, let's say Orionix. So we could do PPK with what we have with the GNSS receiver we have on a LiDAR sensor. So our positioning was PPK. After we do all the workflow, let's say our anchor to ground point is the point we had already fixed, where we put our base station.
All right. And then two questions about, I'll just kind of try to combine two questions together in one. This is concerning the LiDAR sensors. Maybe Max, you can try to take this. So first one is, so how many returns does that LiDAR sensor have that was used for the project? And second one, from another viewer is, what's the points per second for that LiDAR? So how many returns and what's the points per second?
Okay, so to answer this, I can answer this question in two types. First of all, like from a technical point of view, our sensor has 2 returns or 3 returns, and you can capture 2 or 3 returns. But in reality, it totally doesn't matter if you use 3 returns or 2 returns. The most important issue is how accurate is your returns. And sometimes you can capture 1 million of points, and finally all these points will be noise. And you can check it on a hard surface, or you can check it on the trees when, or on the power line poles when the diameter of the tree or power line poles became two times bigger than in reality. And the same situation in the level of noise on the ground. So I wouldn't suggest to look at the technical conditions like how many returns. You should look on the quality of the point cloud, the number of noise, and how the LiDAR penetrates the forest. For example, we have 2 different LiDAR systems. First of all, it's L1, and another one, first of all, is LiveVox, and another one is a Velodyne sensor. All these systems has 2 different kind of capturing of the data. For example, Velodyne sensor has a rotation part of the LiDAR, and it rotates on 360 degrees. And after that, you can capture LiDAR point cloud from different points of view. As a result, you will get a little bit different point cloud. And if we compare with LiveVox, if you use accurate, there are two ways how to capture data in LiveVox. And if you use accurate data capturing with a low level of noise, you will catch just only a thin line of point clouds. As a result, number of points will under the trees will be less. As a result, the representation of the objects will be not so clear, and this is the difference. And in reality, number of returns, if it is 2 or 3, it doesn't matter at all. And the same situation is how many points per second you will get. It's a simple question, but how many real points of the under the ground you will get? How many real points on the trees you will get, which shows you the range, or if it shows the real power line pole? This is the difference. And when you evaluate the quality of the LiDAR system, you need to check the quality of the point cloud and check the distance between objects, check the level of noise without filtering, because of course there are a lot of software which can filter the point cloud, and you will get very thin solution, but in reality it's like half of the meter. It's you need to check the quality of the data, and you need to evaluate the quality of the point cloud. It's the best option, not to look at technical requirements like distance of working distance of the LiDAR, like some manufacturer shows it like 300 meters, but in reality it doesn't work on 120 meters, and in an accurate point cloud you will get in 50 meters altitude. And it's very good example that Christoph said that when they work, when SPH Engineering work in Papua New Guinea, it was a very beautiful project when they fly over the dense rainforest, and they were looking for some objects under the trees, which were stored for a long time. And for that, they use our TOPODRONE LiDAR 200 to fly over the forest to capture preliminary model of the under the trees, and to get the altitude of the trees. And after that, they created 2 different terrain levels. And after that, they were able to fly lower, exactly on a very low altitude under the trees, to capture everything under the trees. And after that, we finally found what they are looking for, as I know. And it was a very amazing project. And I hope that SPH Engineering and UgCS team will show the results of this project and how they use TOPODRONE LiDAR 200 for such heavy to penetrate forest area. So this is the answer.
Yep. All right. So thank you for the answer. And I'll try to answer another one, the questions that's here. And I think it was actually asked by 2 separate viewers. So I think it just makes sense to address. So question is basically about how can you, let's say when the terrain is quite rough, how can you adjust the accuracy at which the software follows the changes in the terrain? And I just quickly want to show you an example of how this can be done. So here you can see this is the hope you can see UgCS screen. You should be able to. So this is the LiDAR area scan that we constructed earlier. And so now, again, if we go here into show elevation, so this is the, oh, sorry, this is for the corridor scan. This should be for the area scan. So yeah, we go here. And so this is the elevation profile that you can see of this route. So there is a way how you can adjust how accurately it is following the terrain. And this is actually done using the following parameter, the AGL tolerance. So you can see that currently the AGL tolerance parameter is set to 3 meters. So this basically means that if the terrain changes by more than 3 meters between 2 points, then UgCS algorithm will insert an additional point in between. But if the changes in the terrain are less than that, then no additional points will be inserted. And so as an example, you can see here, this is the LiDAR area. And so, for example, we have 123 waypoints currently. So now if we want to change this, then if we want to change the accuracy which the drone follows, for example, if we now change the AGL tolerance to 5 meters, we should now, in result, you can see now we are getting less waypoints. So for example, now we're getting 111 waypoints. And if we increase this even more, let's say it's maybe 8 meters, so now an additional waypoint will be placed only if the terrain changes by more than that. And again, so here you can see that now we only have 101 waypoint in the whole mission. So now the drone is not following the terrain as accurately. So if you're flying over some areas where you know that there will be, quite large changes in there, or it will simply be rough according to the terrain elevation model, then in those cases you can play around with this parameter. Or on the opposite side, if you want the drone to follow the terrain more accurately than the mission is constructed, then you can, for example, so let me just select this one. So then you can, for example, enter the AGL tolerance of something like 1 meter. And so now the drone will follow the terrain at quite high degree of accuracy. You can see now our waypoint count is 157. So yeah, I just wanted to answer this question as well. So this question was also asked by Will here. So yeah, basically, like you said, so this is somewhat of a drape over the elevation model that the drone is following when it is flying. Another thing, since I'm kind of here, while we're here on UgCS, I'll just quickly show you how you can add custom elevation. So here, if you go to map options, then map layers window. So then here in this tab of elevation, this is where you can add this. So you can add your own terrain elevation sources, which you can then use to see at what altitude will the drone be. I don't have any prepared now, unfortunately, but if you join tomorrow's webinar, I might prepare some for that. But yeah, they're basically, like I said, you can first use a digital elevation model for calculating the flight itself, or you can use the default one if that's okay in your location. And then if you have some preliminary digital surface model that some rough estimate of where the tops of the trees are, then you can also create a digital surface model, import this into UgCS. You can import this as a GeoTIFF file, for example. And then after you have converted the route to MSL altitude, you'll be able to see the difference between the point and the elevation. So I hope that answers that question as well. So let's see what other questions we have.
Christoph, I saw a lot of questions about LiDAR system, and can I answer to them?
Yeah, of course. Go ahead.
First question: what is GNSS and IMU used by TOPODRONE for precise trajectory estimation? So first of all, I would like to describe the history how we designed the system. As you know, TOPODRONE produce high-precision PPK equipment which can be installed in any kind of DJI drone or an outer drone to convert consumer drones to precise survey tool. And after that, we decided that we can create something bigger, not only in PPK system, not only our own GNSS receivers. And in those time, it was several years ago, the representative of Honeywell, which was based in Switzerland, close to our office, came to us. And we decided to create our own solution for to combine GNSS and IMU. And within 1 year, we worked closely together with Honeywell. And finally, we created a special motherboard, which can include GNSS receiver and any type of Honeywell IMUs and microcomputer to combine all type of equipment together and to get very accurate results. And our aim was to create very affordable solution for LiDAR survey and for any kind of survey like bathymetric survey as well, but with a less level of price if we compare with the planning systems. And finally, after 1 year of development, we achieved great results, which right now you can see in all our LiDAR systems. As a result, we have very low cost solution in comparison with our another one LiDAR system, but we use high precision Honeywell IMUs or Epson IMUs right now, and built by us GNSS receiver and built by us all equipment inside. So this is the answer. We're not only using ready-to-use equipment, we design our own solution, which help us to keep all prices on very affordable level. And as a result, you will get very accurate data sets. And I can show you the data processing, which is very interesting. And I would like to show some parts of data processing. Oh, I couldn't start sharing.
Oh, yeah, that's because I'm sharing the screen. I'll now stop it. So go ahead, Max, and share.
What I would like to show, how to post-process data. It's very simple. What you need to just run our software. Where is it? You need to just run our software. In our software, you will choose data set from the LiDAR, any type. You will choose data set from the LiDAR. After that, you can add offset of the antenna. It's very simple. And finally, you will add base station file, nothing else. If you have already a base station file with precise coordinates inside, in this case, you don't need to change coordinates of the base station. But what more? You can process together different flights together. So you can add additional flights you can add additional flights, for example, and all these flights will be processed automatically. On the map, you can see base station, location of the base station, and starting point of the flights as well. And after that, you just need to run post-processing. Within a few minutes, you will get accurate results. And after that, as soon as you calculate trajectory of the flight, within a few minutes, you can calibrate the LiDAR and you can create point cloud in automatic mode. We just wait for 1 or 2 minutes to get one of trajectory, and after that we can run point cloud calibration. And maybe I will stop post-processing, because the result you will get a trajectory. It's very simple. But I would like to show how easy it is to calibrate the LiDAR and how easy to make strip alignment. It's really easy task. What I need to do is just to stop it. Just to stop. Yeah, and I will run point cloud generation. It's very simple. First of all, we choose the data set. After that, we can choose a trajectory file which was created by our software. After that, it's possible to remove all unnecessary part of trajectory, which is not necessary to generate. And finally, you can choose special options. First of all, you can make a strip alignment for the first data set to calibrate calibration angles for your flights. And after that, you will select type of the LiDAR, and after that you can add additional flights, and you can add as more flights as you want from the same flight area or from any other flight area. And as soon as we use very accurate and stable IMU, angles of the LiDAR, calibrated angles of the LiDAR will be the same. And you don't need to spend a lot of time. You will create a georeferenced LiDAR point cloud automatically. You will create georeferenced point cloud automatically. And what you need, just need to choose a projection, for example, Costa Rica. And we created this option to make automatic strip alignment, especially for Eduardo, which I would like to show you today. That he made more than 30 flights. And if we process data step by step from one by one, it takes a lot of time. But we can add all your flights together, like you can see on our screenshot. And after that, we just run point cloud generation and calibrating of the LiDAR. And there are two options. You can calibrate each flight, or you can calibrate the first flight to calculate angles of calibration angles of the LiDAR. And after that, you can implement to all flights around this area. And as soon as we use high precision IMU inside, these angles are stable, and all flights will be generated in automatic mode within few seconds. So right now, you don't need to use any type of LiDAR 360 software, or for example, software for strip alignment, for TerraMatch, TerraScan software. You don't need to do it. Everything is included inside of our workflow. And everything is made totally automatically. And within a few minutes, the system will calibrate your LiDAR, and after that, it will generate point cloud with using of this calibration information. And all point cloud will be aligned together, and all strips will be aligned together. This is the main advantage of what we made together with Eduardo. And finally, as soon as this calibration step will be done, you will get georeferenced point cloud, and what you need just to make terrain extraction to classify point cloud, and you will get very accurate results. And as soon as it will be calibrated, we will upload the point cloud to any software, and we can check strip alignment. And we don't make any additional strip alignment by LiDAR 360, just the way how we represent it. And all strip alignment was done by our software. So no additional steps is necessary. And this is the answer to the question, what kind of IMU we use. We use Honeywell IMU, which are very stable, and you can process data set automatically.
By the way, Max, there is a question also from a person asking, is it possible to use your software for DJI L1 processing?
Yeah, we saw a lot of questions from the guys that strip alignment doesn't work properly. Why it happened? First of all, it's low quality IMU, which needs to make calibration every 100 seconds. And the second issue, the sensor. And of course, we are developing right now a workflow to use LiveOx datasets, because we use the same sensor like LiveOx Savior, and DJI L1 use the same sensor. So for us, it's not a problem to process the data. If you send us your dataset, we can process it in our software, and after that, we will provide the demo license, and you can test it as well. So you are always welcome to be a beta tester of our software.
And maybe while this software is running, another question we had that was already posted a while ago: what is the point spacing both along and across track?
Does it belongs to the distance between point spacing, point density? Are you talking about density of the points, or distance between flight passes?
I'm assuming this is point density.
Point density. Usually we have like 300 from 300 to 600 points per square meter.
All right. Well, I hope this answered the question. And about the other one that was there about the how to avoid obstruction, I think this was already answered. So I'll mark this as answered.
Yeah. And it's a very good question how to avoid obstruction. And I think it's better when you fly. It's better to look at FPV camera. And if you have camera with the video link on your LiDAR, it will help you to look in both directions, in front of the drone and under the drone. And this is the advantage of our equipment as well, that you can combine camera which has a video link, and you can see, you can watch video from both directions.
Another question there is, when will the version with strip lining, I'm assuming this meant strip alignment, be available? But as I understand,
we are going to publish this version this week. So right now we are finishing all other issues with the software. We have a lot of advantages, and we will have some improvements as well. And this week we will publish this version for all of our users, and you can use it without any problem.
All right, and another one, I think I'll answer this myself. So this is from Wayne. You're asking about, so are there plans to offer remote triggering of LiDAR systems so that we can start and stop acquisition during the flight? Well, currently I can just mention that with one of the things that I maybe didn't mention with the LiDAR tools is that both in UgCS, the LiDAR area as well as the LiDAR corridor, so by default, they both include automatic actions, which will start the LiDAR recording and stop the LiDAR recording after the flight. So this is also included in those flight paths, and you will not see the actions there, but they will happen. So like all you need to do is basically plan either LiDAR area or LiDAR corridor mission, and then the LiDAR will start the recording automatically.
Yeah, Christoph, you are totally right. But what we need to do additionally is to make a better integration between the payload and UgCS. And in this case, it's or you just send the message through export or Skyport for DJI. In this case, we can capture it and we can start and finish survey. But meanwhile, right now, you can cut all unnecessary part of LiDAR data during post-processing. You just cut a part of the trajectory, so there is no any problem. But we are looking forward to create a better integration of all of our LiDAR sensors and camera together with UgCS. And I very pleased that you made a support for our cameras to provide video link. It's very, very good idea as well.
See, there's another question. Let me just read this so I can answer. Okay, so it's about when you're using terrain following, drones following the flight at a certain altitude, after changing the batteries, the height was a bit different where the drone returned. I need to see the specific route that you flew and the altitude that was set there. Without seeing it, I can't really give much pointers on what could have been the issue. But in this case, maybe just send an email to our support team, so support@UgCS, and then we can take a look at the route that you're using, and you just need to collect a bit more information. So this is not enough for me to answer it now, but yeah, I'll also write to you to basically send us an email to our support team.
And Christoph, I saw some message which will be very good for Eduardo, and this is the idea of our webinar as well, to share experience and to provide the context of our clients. And I saw that the guy from Panama, he just said that he has the same project in his country, and he's going to to contact Eduardo. It's a very good issue. That Eduardo, I think it's very good for you as well to contact this guy, and you will show the LiDAR.
We contact you, absolutely, yes. We already have his information. One of the guys from my team, Mike, he's on the attendees, so I believe they spoke.
Yeah, super. So this is the idea of our meeting as well. So let's share our experience and let's share contacts, and maybe you will find a good solution for you. And finally, so right now the system calibrates the LiDAR. We have a different quality of calibration, and if we have a high quality of calibration, it has very high precision measurement and high precision measurement. And right now, all LiDAR point clouds will be created automatically for all flights together. So, and this is why, Eduardo, we process your data sets together within a few days. Just you provided free data sets with free base station, and within 1 day it was totally finished. And in the second day we process the second data set, and so on. So because all data sets are processed very automatically. And do you remember when we made the training, how difficult it was to use Inertial Explorer, how difficult to use another one software to generate point cloud? So right now, time comes, and you may explain users how it is easy to use as well.
Oh yeah, I mean, in the crash course, I was there for the LiDAR training. Like I couldn't sleep, not a single day, because we would go to the training and I would learn all these things, and in so many steps, and then I would have to go at night and redo them a lot, so many times until next day it would be okay. But now with this new workflow that Maxime made for us. Considering we have so many flights, it just made things so much easier, you know, because before you had to tick a lot of boxes and have knowledge of many things in order to get the results done, and you had to practice a lot, and it took some time. And with this new software these guys developed, it really does make it a lot simpler, a lot faster. We don't have to wait so long for the computer to do her part, you know. It's just really more agile, everything.
Very good question from our user as well. Can the TOPODRONE sensor setting be implemented in UgCS software? I think yes. We should talk with Kristaps, and the guys will add our settings, because we test a lot and we work a lot together, and I think it's easy to do. How do you think, Kristaps?
Yeah, I think in the future, it shouldn't really be a problem to have an even closer integration between us and TOPODRONE LiDARs. Okay, so the processing is still continuing. Max, you want to show something?
No, it's everything is finished, and right now we generated point cloud, and as soon as we generate point cloud, we can edit, and finally we can check the accuracy, but you will get totally the same result. So I just add 2 point clouds, which was generated, and we can check the strip alignment between lines, and it was totally automatically generated. And after that, we can check the accuracy of strip alignment between several flights as well. And we can see that they are totally overlapping, and there is no any displacement, what we can see on the screen. So it's amazing quality of the point cloud, because Eduardo tried to fly on very low altitude, and he got very accurate point cloud and very detailed with very low level of noise. You can see it, how clear the structure of the trees. And finally, when we compare alignment between between different flights, we can find that there is no any misplacement, and all data processing is made totally automatically. This is our idea, just to make one button solution, but every time you can change the settings. Every time, it's not a closed box. There are a lot of settings inside of the software, which allows you to set up everything properly. So
we have also one question about is the TOPODRONE strip alignment as accurate as LiDAR 360? Maybe you can comment on this.
Yeah, it's totally the same. If you compare angles of which will be calibrated, it will be totally the same. And right now you don't. Of course, you can run LiDAR 360, and of course you can improve the data, and you can evaluate the data, classify the data in LiDAR 360. But all data sets will be prepared for you automatically. Even all data sets will be cut to the different strip lines. It's very important issue that you don't need to spend a lot of time, and everything will be published all these improvements will be released in a new version of our software this week.
And okay, so I think now maybe I'll just quickly switch on over to what I want to show to you on our website. So I'll just take over the screen sharing for a bit if you're done, Max, with what you wanted to show.
Yeah, I need to switch off sharing. It's switched off, yes?
Now it's still sharing, but in just a moment, you should be
stop
able...
sharing. Yeah. I need to click stop sharing. Yeah. Thank you.
Okay, so now you should be able to see my screen. So I just wanted to come towards the end of the webinar, maybe just show you where you can go to learn more and where you can actually get the software as well. So if you go firstly in our site to UgCS.com, you can of course read about all the features, about the LiDAR toolset as well. And then if you click here on pricing, you will be taken to our shop where firstly, you see this is the UgCS expert license, which you can use for planning the LiDAR surveys. This is what I was showing here. And then in addition to that, if you go up here to UgCS and then LiDAR solutions, here you can find firstly TOPODRONE LiDARs, as well as LiDAR 360 software that was also shown here, as well as TOPODRONE LiDAR post-processing software. So basically all of these you can get from our site. You can also go to TOPODRONE's site and get them there. So this will be topodrone.com. So you can basically go to UgCS, to TOPODRONE, you can read more about everything, and yeah, to make your decision on what sensors, what software are you interested in. And of course, we'll always hear, so you don't hesitate to reach out to us. Yep, after the webinar as well, we will send you the recording of this. So if you want to maybe replay some parts, you will be able to do that. So yeah, towards the end, just want to thank everybody for listening. I think it was quite interesting, and the Q&A section was also very, very interesting for me as well. And yeah, hope to see you in future webinars. And if maybe you have some Spanish-speaking friends who want to join and see this again, then tomorrow we will be doing the same webinar, but in Spanish language. So you can also ask them to join if they want to. So yeah, thank you, everybody.
Thank you.
Thank you. It was a nice
Nos vemos mañana. Nos vemos mañana.